So I can't really say the process it out now, but yeah.
Go back to your exploded view of your PPC model. How does this, where is the structural component of, because currently all these are envelope components, right? So how does the structure sit together with all the rest?
Based on what our civil engineers have proposed, the structure has to be erected in like not together with this.
Okay, I think I try to see, because when I had the chance to do a workshop here some months ago, and in the Q&A after, there were some students who were asking me about irregular shape PPVC. So, of course, the easy way out is to say, okay, let's do escort during transportation, and let's just say swallow the cost. But I was trying to think about how to just like as a mental exercise, how to go about it. And I said, I don't remember who amongst, if there anybody here was there when I was having that very impromptu conversation over there. One of the ideas that came to mind is like, what about a pizza-shaped PPVC component? The widest dimension of which is about 3.4, that basically tapers in. It basically works around a perimeter. So that was one of the thoughts that I had. Is basically, you have basically 4 dimensions. It basically works out as a trapezoid. And so basically the relationship, if the maximum dimension is 3.4, the inner dimension, if you want it to be narrower or wider, that also determines the overall internal radius or dimension of the component. So there is a workaround. So, but of course, if you did such a system, then that means you probably have a 12-meter span across, and you can basically the whole module will have to be, the whole arrangement of modules will have to be so-called, be a little bit more thought through. So there is a way, and I think maybe that's the food for thought that maybe I can impart as to how to maybe achieve certain odd shapes or components, but at least I give credit to some level of attempt to have some form of regularity to the geometry of the building shape.
Thank you.
I'll just, I think the comments are there. Perhaps maybe something a bit more positive. I think the concept of your module for your module gives a lot of opportunity for the eventual design to avoid the tree because of the way it is. Right. So that gives a lot of opportunity for eventually, if this is put in place. So that's very good for this design. I think that's one of the key reasons why you even choose this design itself. But on the sustainability side, can you elaborate a little bit on the energy?
Based on energy, we decided to use IoT systems. So it's smart building technologies, basically. So I'll jump to that slide. Yeah, so basically the device has the ability to without human intervention. So it studies like the human patterns, like for example, Monday to Friday is more for working spaces, right? So so for example, the spaces more for like the public will, such as lighting and stuff, will be toned down. That's how we are going to like save on costs and to be more energy efficient, like in all. Yeah.
Okay. Thank you.
Thank you.
Can I call on Coney Adventures to come down, please? It's your report and the thumb drive.
Okay, I don't know now. Ini kita jangan guna. Nanti udah asli buat ini mantap masih. Nobody on present. Yeah, my mom just told me that to do that. Then I thought you needed to use the beer here and I read it again.
Hello.
Okay, we have Coney Adventurers talking about Coney Island. Give them a hand.
Hello everyone and judges. Our group name is Coney Adventurers and we are representing BC Academy. This will be our group photo and our group consists of eight students currently studying in BC Academy. This will be our content page. This is the showing of roles and responsibilities by each member details. I will go through those things. Like this will be our program schedule details. Let me briefly talk about this. We started this project on 8th of May till 8th of July, so we got about 10 weeks to complete this project, and the rest will be shown on details our process of work.
Sorry, do you have the report? You all submitted the report?
Mr. Kwon. Alright, this will be our site analysis, first topic of our project. And our site located at Coney Island and alternatively known as Polong Serangoon. And the park size will be 87 hectares and opening hour will be 7 a.m. to 7 p.m. And this will be our site analysis. Okay, the main things here, how to access there, how to go there. From Pogo Interchange, you can take bus to go there and walk about 500 meters to go there. And there are 4 nearby parks, and you can see I mentioned their names on the slides. I will go through in details. On above, I'm showing the requirements of our buildings, like maximum 5 stories and GFA and the site area. So next slide I will pass to Dipura. Okay, so for the key strengths, right, for the SWOT analysis is that our site is surrounded by natural surroundings. So because it's in the natural surrounding, there is no disturbance on the island. Therefore, it will be quiet, which means higher productivity. So for weakness, because the site is on an island that is actually very far out, there's actually very poor internet connection, and that is also very inconvenient to get to. So for opportunities, being the only building on the island, it can be an iconic landmark which attracts people to the island. And due to its flexible design, it's also able to expand whenever we want, and ensuring that there is no harm caused to the surrounding damages. And for threat, because there is no entry barrier to the site, anyone is able to enter the building, which could be actually quite dangerous. So this can be easily solved by increasing the security level. So for design concept, because we are being surrounded by nature, we were greatly inspired
by the stacking of blocks concept. So for this, right, the orientation of the building is also to ensure that there is minimum heat gain on the sides of the building, and that the design also allows airflow to flow through from every angle. So it will be naturally ventilated. So being by the seaside, right, because in the day, the sea also, cool air comes from the sea, so it helps to ventilate the area and make it cooler. So for this, right, the good building is not one that hurts landscape, but one which makes landscape more beautiful than it was before. So for this idea, we actually used to support our idea and design principle. So we first started out with hand-drawn sketch, and once everybody actually agreed with the design, we came out with a massing model for visualization purposes and to calculate the GFA of our building. So we actually managed to hit 7,495 meters squared. So actually this shows the process of how the building design is created per level, and the mass blocks are placed in a transverse position to create different visual effects and shapes. So for the floor layout plan, from level 1 to 5, as shown there, which consists of offices, exhibition hall, and etc. So for level 2, 3, and 4, we have link bridges for like the office people and staff to easily get across to another side of the building. So because all our layout is different, it actually helps to shape each other like from different angles throughout the day, so it helps to reduce the heat energy on the building. So this slide shows our front rendered view, side view, interior office, and in the center we actually have a common area whereby people can actually gather and rest in that area. So this area is actually open. It's naturally ventilated as well. It has a sea view, and because there are green walls and buildings at the side, there won't be any sun directly onto the area. So I'll pass my time to Terry.
Thank you, Deborah. Good afternoon, everyone. Now I'm going to talk about our DFMA. In our project, we are going to use PPVC method because it is faster and lesser pollution. So on the left-hand side, it's showing that our PPVC is combined with different parts, which are ceiling, concrete wall, and floor, steel column, and steel framing. On the right-hand side is showing that the steps on how we install our PPVC and apply it in our building. So next one. Next, we are going to talk about our PPVC modularization. So there are two types of modules in our building, which are modules A in red color and modules B in green color. In the first level, we have 22 of modules A and 7 of modules B. So in each level, we have total of 29 modules. In our whole building, there will be a total of 145 modules. So next one we're going to talk about our MEP. So we are going to use the recessed high efficiency Uber light 2 lamps for our lighting features, because it can achieve us to the energy efficiency and save and minimize the cost. For the toilet, we are going to install the special facilities. We try to build in the accessible toilet for those handicaps. And for the air terminal, we are going to install the air supply. The air supply is in blue color and the air return is red color. So both are connected with AHU, which is air handling units, by the duct and flex duct. Next one is showing our air terminal and ducting floor plan using the PVUB method. Next one, I will pass my time to Yasir.
Thank you, Derek. I'm going to present some of the analysis that we've done for our building design, starting with the sun path analysis. So sun path analysis, basically it helps us to establish the relationship between the building site and the sun. So our building is basically facing north and the south. Okay, by analysis actually we found that this direction actually there will be a less thermal heat gain inside the building. So that's why we have placed most of the windows facing north and south, and lesser on the east and west side. Those windows facing the east and the west, actually we have used the material called low heat coating, which will help to gain lesser heat gain. So beside that, on the curtain walls, we have used the wooden panels at a certain angles that it will help to avoid the sunlight penetrate through the building, which will eventually help us to get lesser heat gain. So next I will move on to the shadow analysis. Shadow analysis actually help us to evaluate the extent of the shadow cast by our building around the surrounding areas. We have a video actually to show you actually how the shadows been cast around the surroundings over the different time of the year. Next, I'm going to talk about the solar analysis. Solar analysis basically it helps us to quantify and visualize the distribution and of the